So let me just test to see if I'm recording. Yes, I'm excellent. If I was to say to you, how do we make sure that data traveling from A to B is going to be secure? You would say to me, let's use encryption. Let's take hello, let's encrypt it, let's add some extra characters to it, scramble it up, etc. We send it to the person, then they decrypt it. That's if you want to make the data secure. But I'm going to shift the conversation slightly, and I'm going to say to you, how do we ensure that data, instead of it being secure, it's verified, it's authentic, it's not being tampered with in the first place? Because with anything in life, if I've got a padlock, this is my padlock by the way, that's the worst padlock I think I've ever drawn, so let's try it again. If I've got a padlock, there you go, a little bit better, and the padlock is locked, it is possible to break through this padlock. It is possible to break through encryption. So if they do break through my padlock, I want to know if someone has been in my school locker. So I need someone to detect that someone's been messing around with it, just in case they get through that padlock. That is what we're going to be talking about in this snippet. So we're going to be looking at a type of data verification. This is called a digital signature. So we're going to be looking at a digital signature, which is a type of data verification in itself. So what do we mean by digital signature? What it isn't is someone getting a letter and signing their name on it online. That is not what is meant by digital signature. What I'm going to do is I'm going to explain the process of a digital signature. From this, you would understand the role of that digital signature. Okay, so we've got someone called Alice, and we've got someone called Bob. Alice is wanting to send a message to Bob saying, hello, Bob. What's going to happen next is Alice would want to create what's called a message digest. To create this message digest, what's going to happen is there's going to be a calculation performed on this text, which is then going to be modded. So it's going to take in the calculation the ASCII values of each letter, and let's say it comes to 807. If you add it all up, we're then going to mod it by 100. What that's going to give us is a message digest of 7. You've used this calculation when we mod something by 100 before in other topics. We call this process a hash. So Alice is wanting to send a message to Bob. She wants it to be, well, Bob wants it to be verified to make sure it's authentic. So Alice is going to use a hash algorithm on hello Bob. It's going to be using the ASCII values, mod it by 100, and that's going to create what we call the message digest, i.e. the result. What Alice is going to do next is she's going to encrypt the message digest so that no one can tamper with it at all. So I'm just going to put a little padlock on it to show it's being encrypted. Alice is then going to do the following. She's going to send the message, which is hello Bob. Now we don't have to encrypt this. We can choose to encrypt the message hello Bob, or we can just send it as plain text. We could use asymmetric encryption on this, which will first of all scramble all up, etc. But I'm just going to send it as plain text for now. So Bob is going to get the message hello Bob. He's also going to get the message digest, which is in the padlock. Bob is then going to decrypt the message digest. Bob will do this using Alice's public key. Bob will then generate his own message digest on Hello Bob, and hopefully it would match 7. We'll compare. Yay, it matches. So it hasn't been tampered with at all. So we are in this situation encrypting using asymmetric encryption the message digest. We could also encrypt the Hello Bob message using asymmetric encryption. That will work just as good. So we call this whole process the digital signature. The very moment we encrypted the message digest, why did you say that is? That is the digital signature. So if we were to send a message without a digital signature, without caring about it being verified, the message would be sent without the message digest being created, without the hash. Now the reality is, we could quite easily encrypt this using asymmetric, but it could be somehow on the way tampered with if someone's to break through that encryption. By having a message digest, it gives us that extra layer of security by having that digital signature. So to progress this slightly, in our syllabus we've got to be able to understand these 2 points. How the keys can be used to send a private message from the public to an individual organisation, or to an individual or organisation, shall I say. Or how keys can be used to send a verified message to the public from, like, government. So let me give you some examples of what this means. This could be email encryption. If I was sending a message to Netflix using encryption, or if I was sending a message to the UK Passport Office to send a photo of myself to the UK Passport Office to get it renewed, I want that photo to be encrypted. So that'll be me sending it to an organisation. How would I use keys in order to do that? It could mean if I was, for example, sending a contract, a digital contract over. So I sign it in real life, I print it off, I sign it. Let's say to work at my school. I then send it, but on a secure website, not email, to the organisation. It could be talking about secure online forms. So anything which is going to be secure, and that's key in essence, anything which is containing some sensitivity, that is what this is talking about. From the user, from the public, to normally an organisation or to another person. This is looking at how the keys can be used to send a verified message to the public. So that could be like the government sending a message to everybody in the country, which the UK did recently on a phone alert. So everyone got a phone alert just to test it out for emergencies like earthquake or something. Or it could be things such as software updates. So you've got a company and you are basically wanting to send out your software to update. Let's imagine it's a game, so let's say it's Valorant, and they're going to update all their users. With this, they're going to send encryption, and they're going to make sure it's verified so the public know it's legit from Valorant. So when it downloads, it checks to see, is this from the real Valorant? So in this case, is this from the government? Yes, it is. Yes, it is. Yes, it is. Yes, it is. So you notice that there's a couple of things. This talks about verification. This doesn't mention anything to do with verification in itself. So if we had to talk about these 2 points, they are different. And that's what we're going to do right now. How would we answer this or this if it was a type of question which we might find in an exam? So let's talk about the email scenario. I want to send an email to the passport office with my photo. I want it to be secure, so I'm going to use keys, i.e. keys plural, asymmetric encryption. How does this work? Well, me, passport office. The passport office are going to send me their public key. I'm then going to encrypt the message using the public key. Very simple. I'm then going to send the passport office my photo. And it's going to be the passport office who's going to be able to decrypt it using their private key. So this is basically talking about general asymmetric encryption. Individual, passport office, I need to receive a public key. I know it's from the passport office because we've got a secure session. I then send it to them, and then they use their private key to decrypt it. But when we're sending it out to many people, so let's look at the second one about keys used to be verified. This is going to be quite a bit different because we also need to ensure that there's a level of trust there as well. If we're receiving something from a company or an organization to many people in the public, it is, how do we know it's you in the first place? In a passport example, here, I'm the one who instigated that communication session. In this situation, it's the reverse. So I need to make sure that there's some verification going on. So what would happen with this? Let's talk about, let me just erase this. Government and me. What's going to happen first is the following. The government are going to send out a message saying tax increase. Then what we're going to do is they're going to create their digital signature. To create their digital signature, they're going to use a hash algorithm. They're then going to have a message digest. The message digest is a calculated result of that hash algorithm. Let's say 100. Let's say 10 actually, because you mod it. Then, to create that digital signature, the government are going to use on here their private key. So it's a private key on the message digest which creates the digital signature. We've never done it that way before. Normally we encrypt using the public key. So the government encrypts it using a private key, just the message digest. They may want to encrypt this tax increase message as well, but it's not that confidential because this is just like general information to say that everyone's tax is going up by 10%. So we're not going to encrypt the message, we're just going to encrypt the message digest because we just want to make sure that I know no one's tampered with it and it's from the government. The government don't care about the message being encrypted, just for digest. So what happens next is the message is sent, as well as the message digest, or shall I say the digital signature, because as soon as it becomes encrypted, it's called a digital signature. The government will also send me their public key, which anyone can have. And this public key is able to unlock a private key. So by me just tapping this, tap, tap, the encryption goes, and I can see that the message digest value is 10. I then can perform the hash algorithm, create a message digest of 10 and compare them and say it's verified, it's valid. So the focus of this, again, it's all about verification, making sure that no one's tampered with the message when it's been sent, ensuring that I've got that confidence that no one's tampered with it and it's authentic in the first place. How do I know it's authentic in the first place? Well, the public key, only the public keys sent by the government can be used to check the message digest. If it was not from the government, the message digest will have a private key. I'll be receiving this public key from somewhere else, and it won't be able to basically decrypt the message digest in the first place, so I won't be able to do the hash algorithm. So I'm checking to see if it's verified by seeing if it's been altered or tampered with, and it's from authentic source. So it's all about being authentic, integrity. That's our key points when it comes to verification. So what does this kind of look like as a question? Pause the video, give this question a go yourself first. Okay, so this talks about government again. Sanjit, replying to Sanjit, needs to be verified. How does asymmetric encryption, how is it used to ensure that a message has been verified? Well, step one, if I do government over here and I do Sanjit over here, the government create a message digest on message content. Then I'm going to talk about the message digest, MD, is encrypted using the government's private key. Then the government, I'm going to mention this creates a digital signature. The government sends message and encrypted message digest / digital signature to Sanjit. Sanjit decrypts digital signature using gov public key. Sanjit, I don't know why I'm writing Sanjit again because we know Sanjit, recreates the message digest using hash, and then if both MD equals match, message verified. Happy days. So very quickly, the purpose of SSL and TLS. Give that a go yourself first. Write out what you know about it. I'm then going to go from an A-level perspective. So SSL and TLS, they are protocols, so secure protocols. So these protocols are used when we're transmitting data. Now, TLS is basically an improvement over SSL. It's used way more than SSL. But even though everyone says SSL, really we're talking about TLS in real life. So other purposes, it allows us to have encryption. So asymmetric encryption is carried out when we're using SSL TLS. It allows us to have authenticity to ensure that the server receiving the information from are legit. And it allows us to have data integrity to ensure that no one is tampering with data whilst we're sending things. So if we've got Netflix, you've got me, I want to make sure that when I'm making my request, it is actually to Netflix. So Netflix will send me some information back, which I will then be able to check to see, yep, you are the legit Netflix. Then, when I'm sending information to Netflix and Netflix is sending information to me, I don't want anyone tampering with that information. So it allows us to have the integrity aspect as well. So that is an overview of SSL. I will add a little bit more technical jargon to this as we go along, such as the certificate of authentication. And we're going to look at how that certificate of authentication is made, what's involved in a certificate of authentication as well. We're also going to be looking at the whole process of SSL and TLS in terms of what is going on behind the scenes. But before we do that, a quick note. You may be asked, where would you use SSL or TLS? So different places. You can talk about online banking. I'm going to put in brackets secure. Online shopping, secure. You could talk about secure emails. Notice this word secure because all of these things can be done without it being secure. Secure file transfers. So that could be sending files from one person to another, or it could be sending files from a computer to a server where you've got all your web pages on there using FTP. All of this will be different purposes of or reasons to use SSL or TLS. But before we go any further, let's talk about how SSL/TLS works in general GCSE terms. So we know that step one, the user makes a request to the web server. So the browser makes a request to the web server. The server will then send its certificate of authentication to authenticate itself. The browser will inspect this certificate of authentication. It will then open two-way encrypted communication using asymmetric. So we're going to now take a deep dive into the certificate of authentication. So we're zooming in on the certificate of authentication. What I'm going to do is I'm going to guide you through the different parts of what a certificate looks like. Appreciate this is just like a visual representation. First of all, you have the certificate authority. These are the guys who create the certificate. You have different ones all over the world. So the BBC in the UK would have to apply to the certificate authority to say, yo, I want a certificate of authentication. These are the guys, when we're checking to see if it's authentic, we look for, who provided this certificate in the first place. So this adds the authenticity to it. We then got the organization name. This is the person who we're giving the certificate to, i.e. the BBC. And along with that, it's the main name. So really I should have done this on my little drawing. BBC is the organisation and the domain name is bbc.co.uk. Every certificate has a serial number. It's unique. It basically is there to help identify and manage certificates. So the certificate authority will be responsible for managing all the certificates they give out to the different organisations, i.e. Netflix will have one, blah, 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 blah. Fancy Learning will have one, blah, 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 blah. Loads. And it'll be a certificate authority which will be responsible for managing all of that. In here, we also have the subject's public key, i.e. BBC's public key, so that anyone is going to be in a position when it's used by the client to encrypt or decrypt data, well, to encrypt data, shall I say, rather than decrypt, and to ensure that we have our two-way encrypted communication. And I'll talk about that a little bit more when we go through the steps. We then have the digital signature of the CA. And we know what our digital signature is already. It'll be the content, modded, message digest, encrypted. We then have a valid date, which will have a start and end date of the certificate. Certificates can expire. If you're working with a website, so you want to go on a website and we've got an expired certificate, your browser will have like an error message saying, certificates expired. Are you sure you want to be talking to this website? So these are the different parts of a certificate. You've got the organization name, you've got the certificate of authority, you've got the domain name, you've got the serial number, the subject's public key, a valid date, and the CA's digital signature. This could well come up as a question on your exam. So how does this actually all work? So the next step we're going to look at is the application of a digital certificate. So how do we actually obtain, or how does a business obtain their own certificate of authentication? So let's talk about the BBC. The BBC register their domain bbc.co.uk, but the website will be unsecure. What they want to do is now get themselves a certificate of authentication. So they're going to select a certificate authority. That'll be their step one. Select a CA. What the BBC will do now on their machine, on their server, is create a private public key pair. So they'll generate that using software, cryptography software on their computers. As we know, their private key is just for them. Their public key is for the public, hence the name. What the BBC will then do is they'll do an application. It's called a create a certificate signing request. It's an application to get one of these bad boys. So certificate signing request, which they're going to then give their details. So they're going to send their details on that form. So they're like organization name, their domain name, etc. Now, what happens next is this request, the CSR, certificate signing request, is generated. So it's not like filling out an application form. It's generated by using the same software, the same cryptography software, that we created our public and private key. And what happens is, using the private key, it signs, so like a digital signature, the CSR, our application. So we've got, like, imagine it was like a digital application form. We've got our information on it, like our name, domain name, and we signed it using our private key. It's then generated using cryptography software. The next step is that we simply apply to the certificate, the CA, sorry, not COA, authority. So we apply to them, giving them our CSR. They will then, CA will verify our business. So once they've verified, 7, the CA will then sign the digital certificate. Or shall we say they'll create the digital certificate by signing the public key with its private key. What do I mean by that? This is a CSR application on my left hand side. The CA are going to create the certificate. They're going to take the information from here and put it onto the certificate, but also they're going to have their digital signature. The digital signature, as I mentioned before, is going to be the following kinds of information. The domain name. It's also going to take the public key of the BBC, which they send us. And what it's going to do is it's going to create our hash algorithm. It's then going to create our message digest. We're then going to, or we're not, the CA are then going to use their own private key to then encrypt that message digest. So to create their digital signature. So that happens in that next stage. So the CA will sign the public key, i.e. they'll combine the BBC's public key with the other information to create the mod, to then create the message digest, which is then going to be encrypted, using the CA's private key to create the digital signature. Then, in this process, step 8, CA sends the organization, i.e. BBC, the digital signature. The digital certificate, so I'm going to do COA, Certificate of Authentication, and then the BBC install it, install the certificate on their server, so that when we make a request, we access their server. So in layman's terms, we've got step 1, a web browser asks BBC server to authenticate itself. BBC would have had to apply to get a COA, so that's what we've just talked about now. On the BBC server, it'll send the web browser the certificate of authentication. That is basically what we've just zoomed in on. What we're going to do now, though, is we're going to look at things in a little bit more detail with a focus on TLS. Okay, so TLS is split into 2 parts. Do you know there's 2 parts? Pause the video, give it a go yourself first. Alright, so we've got record and we've got a handshake. So what is a record? What is a handshake? Really, really simple. The record is responsible for, I don't know why I just wrote there. So the record is responsible for handling the secure transmission of data. That's its job, to make sure that the data is being encrypted, also compressed, and also it's got the same integrity, not been modified. The handshake is part of what we could say is the negotiation between a web server and a browser. So my browser says to BBC, yo, how's it going? Let's talk to each other, but I need you to prove to me that you are who you are. I want to be using some encryption as well. That would be the handshake. The handshake will be involved in the certificate of authentication. The handshake will be involved in the switching of the passing of keys to each other. That would be the handshake, getting ready to talk. The record is just managing all of that in essence. So let's look at that in a little bit more of a structure. How does it all work? So if I was to say to you, write the steps of SSL, you're pretty good at doing that, I'm sure. If I said to you, write the steps of TLS, well, we know it's the same as SSL, but we can go slightly deeper. So when we're talking about TLS, let's go into that a little bit more detail. We've got my browser. We've got Netflix server. What will happen behind the scenes when I load up Netflix? So I type in www.netflix.com. My browser will basically make an initial connection. So I'll write here, initial connection. And I'll send and this is a term, client, so I'm a client, hello message. So my browser is a client with a customer. Netflix is the provider, the server. We will make an initial connection by saying hello to Netflix. Netflix, the server, will respond back to me. So they will have a server hello message. So it'll be like, hello. So I go hello, they go hello. Whatever. And they're also going to give me their certificate of authentication, and they're also going to send me their public key. What happens next is the following. My browser, like Google Chrome, will, or let's put down here, so Netflix, my browser, will verify. So they'll make a verification of the certificate. They'll then do the following. They'll use the server's public key. And what will happen is it'll create, so it'll add to that public key a little message. So we call this little message a pre-master secret. So this pre-master secret will be like a little bit of text added to the public key. So it'll be the server's public key and this pre-master secret, which my browser will create, which will generate what's called a session key. So let me just say that again. Initial connection, I send a hello message. Netflix will send me their public key, the certificate of authentication, and like a hello message back from the server. My browser will then verify the certificate of authentication. It will then use the server's public key, and it will make a little secret message on my browser called a pre-master secret, and it will combine them both together to create a brand new key called a session key. This session key is going to be used by both my browser and the server of Netflix whilst we are in communication for this session, so i.e. before I log out. So this session key is shared between the server and the browser. This means that this key is going to be used for any encryption going on between us and decryption going on between us. That is TLS. Now, just to put this in a nutshell, what we have is all of this is going to be, well, up until the actual session key creation, all of that is part of our handshake. So again, what happens in TLS? Step one, browser, initial connection, client hello message. Step 2, server hello message, public key, certificate of authentication. Step 3, browser verifies COA. It gets a service public key and it combines it with a pre-master secret to create what's called a session key. These session keys are unique. So they are unique. No one else can have one of these session keys for the session. So unique keys for the session. It allows us to have this secure channel. So the use of session keys, that even if one session's keys are compromised, it's not going to affect any future sessions because we create new keys. So that is TLS in a nutshell. Those steps. So to recap, we've looked at the following. We looked at what is used to ensure that data is kept secure. So that's talking about asymmetric encryption and symmetric encryption. We've also looked at how to ensure that data is authentic / it's got high integrity. And that is where we talk about the digital signature. Where's a digital signature used? Well, it's used on secure email. It's used on things like blockchains. It's used on legal documents, which are digital. It can be used on software updates. Certificate of authentication, etc., etc., etc. We looked at the creation of a digital signature. We looked at how it's actually done using the algorithm, the hash algorithm, then it's creating a message digest, which is then encrypted. We then looked at the difference between when we talk about secure and authentic, when we're using asymmetric encryption. This would be just your traditional steps. So if you say, how is asymmetric encryption used for security? You'll talk about the how the public key is sent from the receiver to the sender, how the sender will encrypt it using the public key, how the receiver will then decrypt it using their private key. If we talk about authentication, we'll talk about how the digital signature is used with that message and how it's then received by the other person, who then does the same algorithm to create the same message digest, to compare the message digests to see whether or not they're valid or invalid. We then looked at SSL in basic steps, and we had more of a focus on TLS. But for both of these, we looked at the certificate of authentication. We looked at the different things which are part of that certificate of authentication. We also looked at, in more detail, how companies apply for a certificate of authentication. We also looked at the steps of how TLS would work in more detail, which involves things such as the session key, etc. So that was what this video medley was all about.